gedoen het. Hierdie moet vir jou bekend lyk die grafiek. This graph should look familiar to you. This is an exothermic graph. Okay, now how do we get here? At exothermic, on the y-axis we have energy, and this is actually the potential energy measured in kilojoules per mole. So how many energy is given off for 1 mole of molecules? And on the x-axis, it can be two things. It can either be time or it can be reaction coordinates. Okay, so dit is of tyd of reaksie koördinate. Dis 'n weird ding wat hulle daar vir jou gee. Dis maar net hoe vinnig die reaksie gebeur. How fast the reaction takes place. Okay, so that's our y and our x-axis. Then we have the energy of our reactants here. Okay, so kom ons sê die reaksie. Let's say we have the reaction of zinc with hydrochloric acid gives us sink met soutsuur gee vir ons. Now, this gives you zinc chloride. And remember, zinc has a 2 plus valency, chlorine has a 1 minus valency. Zinc is 2 plus valency, chlor is 'n minus 1 valency, wat beteken dat ons 2 chlore moet hê. It means we must have 2 chlorines, and then it gives off hydrogen gas as well. Dit gee jou waterstofgas ook af. And if you balance this equation, you get 2 hydrochloric acids, 2 soutsure. Okay, so I'm going to use this reaction as an example here. Ek gaan hierdie reaksie gebruik as 'n voorbeeld daar. Okay, so the reactants will then be zinc and hydrochloric acid, zinc en soutsuur. Then we must split this hydrochloric acid apart. And to break it apart, om dit uitmekaar uit te trek, kort jy 'n tipe energie. Jy kort daar die dissociasie energie, the dissociation energy. So from here to here, when you go up, that there is called the dissociation energy of die dissociasie energie. That is the energy needed to break a bond. Dis die energie wat nodig is om 'n binding te breek. And in this graph, we also speak about the activation energy, die aktiveringsenergie. The minimum energy required for a reaction to take place. Die minimum energie wat nodig is vir 'n reaksie om plaas te vind. Nou, al hierdie definisies is in jou graad 11 notas. All these definitions are in your grade 11 notes that you have to keep. Yes. I'm just going to give you a quick, show you where you did that. You had notes that look like this. These notas wat so gelyk het. Yes. And on the previous page there, it gives you what is the heat of the reaction, aktiveringsenergie, activated complex, catalyst, blah, 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 blah. Yeah? So this chapter you must find again. This is an important chapter. Okay, hierdie was hoofstuk 9.1. Hoofstuk 9.1 van jou graad 11 notas. Moet jy weer gaan hersien. So chapter 9.1 of your grade 11 notes, you must go revise again. Pieter, onthou my dat ek jou vir jou copy. Okay. Goed. So daar kry jy die dissociasie energie, the dissociation energy, the energy needed to break the bonds, or it's called the activation energy, die aktiveringsenergie, die minimum energie benodig vir 'n reaksie om plaas te vind. The minimum energy required for reaction to take place. Hierdie is die 3de keer wat ek dit noem. So dis belangrik. Okay. Then when you get to this point there at the top, we usually write it in brackets. So I just don't have a lot of space. So at the top there bo dit skryf ons sink en ons skryf sout en ons skryf chloor. So you write all the ions, al die ione. So hulle is almal in ion vorm. They are very unstable. Hulle is onstabiel. And they are ready to bond. Hulle is reg om te bind. Okay. Now that there at the top we call the activated complex, die geaktiveerde kompleks. the activated complex of die geactiveerde kompleks. Alright, so then they rearrange, hulle herrangskik, lekker, and they're going to bond again, hulle gaan weer met mekaar bind, and when they bond, they become stable, dan gee hulle energie af. So wanneer hulle bind, word hulle stabiel en hulle gee energie af. So daar waar hulle bind, there where they bond, they give off energy. En daai energie wat hulle afgee, noem ons die bindingsenergie. We call it the bonding energy. Well, I want to write here, this is the energy given off. Dis die energie wat afgegee word. And the dissociation energy, hier aan hierdie kant, the dissociation energy is the energy needed. Energy needed or required. Die energie wat benodig word. Aan die linkerkant. Okay, dan if it gives off more energy, so jy kan sien, hy gee meer energie af as wat hy nodig het. It gives off more energy than it needs, then it gives energy to the environment. Hy gee energie aan die omgewing, wat beteken hy maak die omgewing warm. Okay, nou die omgewing hoef nie te wees soos, hy word koud en die omgewing word warm nie. Hy word self ook warm, omdat hy die omgewing warm maak. Okay, so if I say it makes the surroundings warm, it doesn't mean the substance gets cold and the surrounding gets warm. It means itself also gets warm because it makes the surroundings warm. Okay, so if, I don't know where we're going to write this down. So if the bonding energy is greater than the dissociation energy. So die bindingsenergie meer is as die dissosiasie energie. Beteken dit, hy gee meer energie af as wat hy nodig het. Dan is dit 'n exothermiese reaksie. Then it's an exothermic reaction. Dan is dit 'n exothermiese reaksie. Okay, and the way you write it down with an equation is you either make a comma, jy maak so 'n komma aan die einde, and then you say the heat of the reaction, die enthalpie of die reaksie hitte, is kleiner as 0, smaller than 0. Ek gaan nou sê hoekom. Of jy kan sê, die enthalpie is sê maar 'n waarde, they'll do a calculation and they give a value, and let's say it's minus 150, I don't have space, kilojoules per mole. Okay, Anay, hoekom? Hoekom is dit 'n minus? Hoekom is dit kleiner as 0? Okay, jy is reg, maar jou bewoording is klein bietjie verkeerd. Jy moet sê hy gee meer energie af as wat hy inneem. Want hy gaan altyd afgee. Okay, so why is it a negative? Because it gives off more energy than what it takes in or what it needs. Okay, so hy gee meer energie af as wat hy benodig. Dis hoekom dit 'n negatief is, of dis hoekom dit kleiner as 0 is. Right, and then last thing that I want to add there is you also get something like a catalyst, 'n katalysator. En wat 'n katalysator doen, is die heel belangrikste ding, is hy verlaag die aktiveringsenergie. So a catalyst there, I'm going to say there, a katalysator, verlaag die aktiveringsenergie. It lowers the activation energy required for a reaction to take place, vir 'n reaksie om plaas te vind, and then it speeds up the reaction. So it means it ends faster. Maak vinniger klaar. It ends faster. So it does two things. It lowers the activation energy and it speeds up the reaction. Okay. Enige vrae daar? Anything that I must repeat or explain? Dan net 'n klein bietjie onder. Just an endothermic reaction. An endothermic reaction will obviously end higher than where it started. 'n endotermiese reaksie gaan hoër eindig as wat hy begin het, as waar hy begin het. Okay. They can ask you to draw a graph like this. Hulle kan vir jou vra om dit te teken. Hulle kan ook vir jou vra om dit te lees, to get information from it. And they can ask you to complete the reaction. So baie keer gee hulle dit vir jou. A lot of times they only give it until there. And then you must complete it. Does it end higher? Does it end lower? Okay, goed. Dit is graad 11 werk. This is grade 11 work. Now I'm going to go to grade 12 work. Okay. Now, before I do that, I quickly want to show you a YouTube video. Okay, and this video explains the whole chapter. Hy verduidelik die hele hoofstuk. And you'll see it is such an easy chapter. Dit is so 'n maklike hoofstuk. Maar die vrae is moeilik. The questions are difficult. So the concepts are easy. The questions are difficult. Okay. Bless you. Dankie. Sorry, ek het net gevinnig.
Meet our chemist, Harriet.
Nee man.
Battery 90%.
Moet my vrou later te pauze.
She has a chemical reaction that needs to occur more quickly. Our chemist...
Okay, Melanie. Mag gou met hom connect.